If you are building a puzzle game or need gameplay mechanics involving laser beams, reflections and physics-based interactions, this is the plugin you have been looking for. Designed with flexibility in mind, the Laser Interaction Kit gives you powerful tools, without the need to modify any source code. The plugin is built around three core components. The emitter, the source of the laser beam. It controls the ray's origin and core behavior. The reflector, used to bounce the laser in custom directions. Place them freely in the scene to guide the beam with precision. The Pushable, applies physical force or impulse when hit by the laser beam. In addition to these core components, the plugin includes three optional components that give you even more precise control over the laser system. The LaserOrigin lets you visually define the exit point where the laser beam starts, directly from the viewport, perfect for fine-tuning the behavior of the beam. The LaserDirection allows you to set the beam's direction visually in the editor, giving you full control over how the laser reflects or splits without needing to write code. The LaserForceTarget lets you specify the exact physics point that the pushable component should apply force to. Each component comes with its own configuration asset. This means you can tweak the behavior of multiple actors at once, simply by adjusting a single configuration file. At its core, the system relies on highly optimized line traces. A customizable ray is projected, detecting all overlaps until it hits a blocking object. Let's start by configuring an emitter and see how the system behaves in action. Create a new actor. I'm gonna call mine BP my first emitter. Let's add a static mesh component. This will represent the object from which the laser is projected. Keep in mind, having a mesh is not strictly required, as the laser system doesn't depend on mesh components to function. Now let's add the laser emitter component and assign it a configuration asset, which we will create next. The emitter configuration allows full control over the beam behavior. The collision channel chooses which objects the laser can detect. The beam radius adjusts the width of the laser. Max distance, how far the laser travels before stopping. Max bounces, define how many times it can reflect. Custom mesh, use your own mesh and materials to render the laser visually. Niagara effect, add particle-based visuals with full parameter control. Trace debug view, helpful for testing and verifying beam accuracy. To activate the laser, simply call the traceLaser function on the emitter component. You will need to provide two parameters, the starting point and the direction, both in workspace. Compile the blueprint, and just like that, your first laser beam is live. The reflector works in a similar way. Let's create a new actor and add a static mesh for visual purposes. Although just like before, it's not strictly required for the system to function. Now we add the reflective behavior component. Create a configuration asset and assign it to the component created. . Reflectors offer 5 unique reflection modes. Specular, a realistic mirror-like behavior. Orthogonal, reflects the beam at 90 degrees, regardless of input angle. Split, splits the beam into 2 opposite directions. Explicit direction, use visual helper and components to define 1 or more custom reflection angles. Custom logic, implement your own logic via Blueprint or C++ for full control. Reflectors can also override emitter settings like laser length, visual style, or effects. To enable physical interactions with other objects, let's create a new actor and this time add the Pushable component. You can set the force magnitude, choose between impulse or continuous force, or define the push direction. And now, the most important part of the setup. You need to enable physics on the component you want to interact with, and then add a force target component as its child. This approach gives you great flexibility, allowing you to work with complex blueprints that have multiple body instances, while still applying force to a specific one only. Actors that implement a laser exposure interface can respond both when they are hit and when they are no longer hit. This makes it easy to trigger on-off behaviors, such as toggling doors or activating machinery. In addition to that, the emitter raises a non-laser hit event every frame. This event provides information about the actor's hit and the exact point of collision. It's ideal for external systems that need to track the laser's current state, or for implementing time-based mechanics, like charging a device while the switch is held down. Need to know exactly where the beam hits? Query emitters and reflectors at runtime to get precise data on ray paths and collisions. Perfect for placing particle effects, triggering gameplay, or syncing with other systems. Laser Interaction Kit was used in real production scenarios. It's flexible, powerful, and easy to integrate into projects. Need a feature? Got questions? Reach out. I would love to hear what you are building. Thanks for watching.